How are you, my friends? This is Calculus 1 solved questions about curve sketching, and this is part number 3. Please, you can go and check parts number 1 and 2 for more graphing questions. I will call this video all-in-one graph question. Sketch the graph of the rational function f of x is equal to 2 plus x minus x squared, all divided by x minus 1 squared. So this is a rational function. It will take time to graph it completely. Let me give you an important remark about this question. Now, the solution will take almost 8 slides, which is too long. So please do not panic. This question can be divided into 10 or more short questions suitable for any exam. Like, I'll give you some examples here. We can say, for this rational function, we can say find the first or the second derivative. That will be a question. We can say find all critical points. We can say ask where the function is increasing or decreasing. We can ask find all inflection points. We can say where the function concaves up or down, or we can say find the vertical and horizontal asymptotes, and many other questions. So please enjoy the detailed solution. Now the function is f of x, as I mentioned before, 2 plus x minus x squared divided by x minus 1 all squared. So in this slide, I will find the first derivative only. We can see this is a quotient, so we can use quotient rule, u prime v minus v prime u divided by v squared. This is from lecture number 7 in Calculus 1. So the derivative of this u prime, 2 plus x minus x squared all prime, x minus 1 squared, this is v, minus the derivative of x minus 1 all squared times the u, which is 2 plus x minus x squared, over all v squared. Now the derivative here will be 1 minus 2x, easy. We can leave this x minus 1 squared. The x minus 1 squared, the derivative will be 2 times x minus 1 times 2 plus x minus x squared. We can take here x minus 1. You can see that as a common factor to make it easy. X minus 1 out. Now inside we have 1 minus 2x times x minus 1 minus the 2 here times this big bracket, 2 plus x minus x squared. And here we have x minus 1 to the power 4. Let's multiply inside the bracket. This is a FOIL method. So 1 times x will be x minus 1 minus 2x squared plus 2x. And this one here, multiply minus 2, distribute on this. It will be minus 4 minus 2x plus 2x squared. Now you cancel x squared. X minus 1 here, canceled with 1 of the x minus 1, so it becomes x minus 1 cubed. Let's see the x's here, minus 2x plus 2x. Cancelled will be only 1x, and the numbers minus 4 minus 1 will be minus 5 here. So f prime, final answer for the derivative, first derivative will be x minus 5 over x minus 1 all cubed. So this can be one question. Now let's continue. Take the first derivative here from the last slide, x minus 5 over x minus 1 all cubed. Let's find the second derivative of the function. So this is the second derivative. Also, we can use quotient rule. U prime v minus v prime u divided by v squared. So the derivative of x minus 5, which is 1, x minus 1 cubed minus the derivative here of x minus 1 cubed times x minus 5 over all this squared. So it becomes x minus 1 to the power 6. Now we can notice here x minus 1 squared is a common factor. Inside the bracket, we have 1 times x minus 1 minus 3 times x minus 5. So let's multiply inside x minus 1 minus 3x plus 15. So it will be 15 minus 1, 14 minus 2x. Okay. Now we can take 2 as a common factor there, and we can cancel here x minus 1 squared with x minus 1 to the power 6, and we have to leave here x minus 1 to the power 4, because 2 minus 6 will be minus 4. In the denominator, it will be plus 4 in the power. So the second derivative final answer will be 2 times 7 minus x, all divided by x minus 1 to the power 4. That's another short question. Here we take the first derivative and we find the critical values. The critical values were f prime is equal to 0, so only x equals 5. Now 1 is not in the domain of the function. See, it will make the denominator 0. Otherwise, we take 5 and 1, but 1 is not in the domain, so we cannot consider it as a critical value. But it should be shown here in the table. This table of sign for f prime. So we write x minus 5, x minus 1, this is x minus 1 all cubed, the same behavior as x minus 1 to the power 1. So just to choose a number here less than minus 1, between 1 and 5, and greater than 5. So you put the table here. F prime is positive, that means the function f is increasing. F prime is negative, the function f is decreasing. F prime is positive, the function f is increasing. So where is the local minimum? Local minimum is at 5 here, you see? And then to find the minimum itself, I take 5 and replace it in the function itself. 2 plus 5 minus 5 squared over 5 minus 1 all squared. You will get minus 9 over 8. You can do it yourself, please. And this is where the function is increasing, minus infinity to 1, union 5 to infinity. And f is decreasing from 1 to 5 open interval. So this is local minimum, and this is also the global minimum in the whole function. Now let's study f double prime. So the possible inflection point is x equals 7. This is from the second derivative. We take the second derivative is equal to 0, x is equal to 7. We have to study that. And 1, we cannot consider it because it is not in the domain of the function f. So x minus 1 to the power 4, we write here plus plus plus. 7 minus x, I choose a number less than 1, between 1 and 7, greater than 7. So the function here concaves up, and then concaves down. So we look, where is the change in concavity at 7? So the function f concaves upward from minus infinity to 1. You can write here union 1 to 7, or you say and 1 and 7. F concaves downward on 7 and 8. So there is a change here. So we have one inflection point at x equals 7. Put 7, replace 7 in the function f. 2 plus 7 minus 7 squared over 7 minus 1 all to the power 2. It will be minus 10 over 9. So this is the point which we call inflection point. This is easy slide here. To find x intercept, this is from algebra course. Put y is equal to 0. So this is the function f of x is the same as y. So cross multiply, you will get the numerator 2 plus x minus x squared is equal to 0. Multiply by minus 1, factor, you get two values for the x equals minus 1 and x equals 2. So these are the x intercept of the graph. Now at the last slide, we will see the graph with all these informations: x intercept, y intercept, horizontal asymptotes, vertical asymptotes, increasing, decreasing, inflection points, critical values, etc. Let's find y intercept. Let x is equal to 0, so y will be 2. Now in this slide, we will find the vertical asymptotes and the horizontal asymptotes if there is any. So for the vertical, we find the limit of the function as x goes to 1, because it will make the denominator here 0. So when we replace x by 1, we will get 2 over 0, which is infinity. That means the vertical asymptote is the line x equals 1. Now for the horizontal, we find the limit of the function as x goes to plus or minus infinity. Or we can take the leading coefficient of the numerator divided by the leading coefficient of the denominator, since we have the same degree in the numerator and the denominator, which is x squared. So minus 1 divided by 1, or we can take the limit, divide all the terms by the highest power, which is x squared. So we will get here, and then take the limit as x goes to infinity. 2 over infinity will be 0 plus 0 minus 1 over 1 minus 0 plus 0, it will be minus 1. So the horizontal asymptote is y equals minus 1. Two more questions left before the graph. Always you can ask, does the graph cut any vertical asymptotes? The answer is no. Does the graph cut any horizontal? Maybe, sometimes, and we have to check this one. So what do? We take the function, put the function equals the horizontal asymptote. So the function here we have 2 plus x minus x squared over x minus 1 all squared is equal to the horizontal, which is minus 1. Now cross multiply. So we have 2 plus x minus x squared. Here we have to expand. So this is x squared minus 2x plus 1 multiplied with this minus. You see that here? Now, minus x squared will be cancelled. Minus and minus 2x will be 2x. Take x on the other side, and this is minus 1. Take it on the other side. X will be 3. Check it, please. Now, to find the y value, 3, we replace it in the function, or we can take it directly from the horizontal. If you place 3 there, 2 plus 3 minus 3 squared over 3 minus 1 all squared, for sure you will get the horizontal asymptote, which is minus 1. So the point 3 minus 1 is on the graph, and the function cuts the horizontal asymptote at this point. Now, finally, let's see the graph on the next slide. This is the nice function, and this is the nice graph. You can put all the information we have done in the last 7-8 slides. See the vertical asymptotes, you start there, x equals 1. The horizontal y equals minus 1. It's below the x-axis. X intercept is there, 2, 0. X intercept is minus 1, 0. The y intercept here, 0, 2. And also, see this point here, 3 minus 1, where the graph, this is the blue, the graph will cut the horizontal, and this is the minimum value. See, this is the global minimum. It will be 5 minus 9 over 8. It will come back asymptote to the horizontal here. See, it will come back close to this horizontal asymptote. And this is the inflection point, 7 minus 10 over 9. And this is everything you need about this graph. For more questions on graphing, you can see the lectures 18 and 20. And for more questions on Calculus 1 in general, you can visit the playlist Calculus 1 Solved Questions. Please, I would like to mention here, this is part number 3 in the graphing. You can check part number 1 and part number 2. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.